Where did we stop last class? We wrote some bidentate, right? Chalo. We'll continue. What were bidentate? The denticity is 2. ठीक है? We'll rewrite the bidentate. वो part record नहीं है. फिर से लिखना पड़ेगा. एक revision भी हो जाएगा. So if the denticity is 2, we call such ligands as bidentate. Now give me some examples. Which was the first one that we wrote? Ethylene diamine. ठीक है? It is represented as EAN. ठीक है? And it was something like this. And the donor atoms were nitrogen. What was the charge? The charge was 0. ठीक है? Or you can say neutral bidentate. Okay, I think this was the first one. Chalo, next. What was the second one? Derivative of glycine, which is glycinato. Donor atoms, oxygen and nitrogen. And charge, please. So charge is -1. Now I'm not writing the donors because the coordinate bonds show the donor atoms. We also write this as just Gl. Why? After glycinato, what was the next one? Oxalic acid. Also called as oxalato. Oxalic acid से oxalato, OX. What was the charge? -2. What was it after oxalato? That was the last one that we did, kya? Okay, chalo, theek hai. Let's continue after this. The next one is, anyone who can try the nomenclature for this? Anyone who can give me the nomenclature? Excellent. Propylene diamine. Or else, anyone, any other nomenclature? 1,2 or propane 1,2 diamine. Again, what's the charge over here? 0, or it is a neutral bidentate. Next, what was the nomenclature for this? This is called as pyridine. What about this? Give me the nomenclature for this. Anyone? Dipyridine. DIPY or di. Also write as dipyridyl. ठीक है? Or dipyridine. Which are the donor atoms here? क्या बात है? Next. I'm sorry. Neutral. Pyridine was neutral. Even this is neutral. Next. Anyone remembers where we did this compound? There was something special about this compound. What was special about this compound? This is keto form. We wrote its enolic form. What was special about its enolic form? Tautomerism के बाद we wrote something like this. This was its tautomeric form. I'm sorry, enolic form. There was something special about this enolic form. There was intramolecular hydrogen bonding, therefore the enolic form was around 76% and the keto form was around 24%. याद है ये कुछ? Very good. किसी को कोई याद नहीं. Now, so the enolic form ठीक है? This is a ligand. The nomenclature for this is called as acetyl acetonato. Okay, also written as ACAC. The charge for this is, anyone who can give me the charge by looking at the structure? -1. ठीक है? That is next. Nitrogen donor atoms. This is called as oxygen. Okay, this is called as phenanthroline. Again, neutral in charge. Okay, I think these are sufficient enough. So this is the structure. These are bidentate. Okay. From bidentate we move on next to bidentate के बाद people we move on next to tridentate. Hmm. Can someone try for the nomenclature here? I think it's the derivative of the first bidentate that we have written. If I give you this, इसका nomenclature क्या था? This is ethylene diamine. So what have we done here? Very good. Diethylene. That is correct. Diethylene. Excuse me. Triamine. ठीक है? How will you represent this? DIEN. What is the denticity over here? 3. I want you to derive for me a denticity 4 wala ligand. What will the nomenclature be? I repeat, I want a denticity 4 ligand. So triethylene tetraamine. Keep on increasing the denticity. Tetraethylene pentamine, so on and so forth. So we are not going to learn anything specific, ठीक है, for denticity 3, 4, 5. However, a very specific ligand that we need to remember is this. Give me the nomenclature for this. For this particular ligand, give me the nomenclature, people. Which ligand is this? This is ethylene diamine. ठीक है? Now I replace one of the hydrogens by acetate ion. So the denticity now changes from 2 to 3. Charge goes from 0 to -1. ठीक है? Now tell me, what is the new denticity? What is the new charge? Charge is -2. What is the denticity? 4. Give me the nomenclature. It started from ethylene diamine. What have we added? Acetate. How many? ठीक है. Now give me the nomenclature. Tetra acetate 2. What's the name of the ligand then? EDTA. Where did we study this? D block elements, maybe did EDTA. What's the charge here on EDTA? So EDTA charge is -4. And what is the denticity? 6. So it's called as a hexadentate. Yes or no? How 6? Which are the donors here? 2 nitrogens and 4 oxygens. If I give you EDTA 3-, what will you call this as? What will the denticity be? Pentadentate. EDTA 2-. so on and so forth. Are you people getting that? बोलो रे. Usually ये ऐसे तो बहुत कम पूछते नहीं है, but if they give you just EDT or EDT 4 minus, that is hexadentate. ठीक है, अगर कभी ऐसे दिया, that would accordingly change its denticity. Did you people get that? Okay, these are the list of ligands that you need to remember. तब तक pause करिए. Okay, so what do we have to find here, people? Find the oxidation number, coordination number of the central metal atom, along with you have to mention whether these are homoleptic or heteroleptic complexes, whether they are cationic, anionic or neutral complexes. Okay, we have to find this. Let's start with the first one. Now, how do you find oxidation number? This is just basic redoxy kar rahe hain. So let's say on Fe, let the oxidation number be X. What is for potassium? Group 1 element? Plus 1. What about glycinato? Please go and check what was glycinato pe charge? Minus 1. And what is this NH? Please go and check anionic monodantates mein we've written what NH is. In anionic monodantates, what was the NH? NH was imido, and what was the charge? 2 minus. ठीक है, minus 2. चलो, now find X for me. तो कैसे कहते हैं people? 2 into plus 1 plus X plus 2 into minus 1 and plus 2 into minus 2, and the overall 0. So how much is X when you solve this? X is equal to plus 4. Did you people get that? Now that is how you find. So what is this X? Oxidation number. How do you find coordination number now? Coordination number ke liye we'll only look at the complex part. What is the coordination number for glycinato? Glycinato is a bidentate, right? And how many such glycinatos are there? 2. So 2 into 2 plus. What is the denticity for imido? 1. How many such imidos are there? So 2 into 1. So total kitna ho gaya people? So what is the coordination number? Excuse me. 6. Next, is it homoleptic or heteroleptic? It is heteroleptic. We have 2 different ligands, so it is heteroleptic complex. And is it anionic or cationic? How do you decide? In aqueous solution, what will this complex look like? When you dissociate this, 2K plus Fe so whether it is anionic or a cationic complex, it is an anionic complex. Did you people get that? Bolo re. Chalo, let's try the next one. Let the charge on cobalt be X. What about ethylene diamine? Check karo EN. What's the charge on EN? 0. What's the charge on Cl? Halogen -1, and ye chlorine be -1. So how do you find oxidation number now? X plus 0. अभी directly लिख दूँ? -2 is equal to 0. So how much is X over here, people? Plus 4. So that is the oxidation number. What about coordination number now? Ethylene diamine. What is ethylene diamine? It's a mono or a bidentate? It's a bidentate. So 2 into how many ethylene diamine? I mean 2 plus. What about this chlorine? It's a monodentate 2 chlorine. Will I consider this chlorine? Why? Present outside. So the coordination number is 6. Tell me whether this is homoleptic or heteroleptic. Again it is heteroleptic. And whether it is cationic or an anionic. How do you decide? If you dissociate this, what will you get? CO, EN twice, Cl twice the whole raised to 2 plus 2 Cl minus. So is it a cationic or an anionic? It is cationic. Are you people getting this? Next. Solve the third one for me. Oxidation number please. What is CO? CO ligand कौन सा है? Carbonyl. What's the charge on carbonyl? This is 0. What will the charge on Fe be? This is X, na? X plus 5 into 0 is 0. X is कितना? 0. Give me the coordination number please. What is the denticity of CO? 1. How many COs are there? 5. So what is the coordination number? 5. Oxidation number was, is it a heteroleptic or a homo? This is homo. Cationic or anionic or neutral? It is neutral. Why is it neutral? Because the charge on it is 0. समझा कि नहीं समझा? Everyone, yes or no? बाकी क्या कर सकते हैं हम? जल्दी जल्दी प्लीज कंप्लीट दिस फॉर मी. पॉज कर दे. ओके. नाउ वी विल गिव यू दिस वन. ये वाला देखो थोड़ा सा एक अलग है. Okay, now we will look at this one. Can someone give me a charge on Fe over here? Let that be X. What about H2O? Oxidation number H2O? 0. Please check for NO. What is NO? Excuse me, nomenclature and the NO is nitrosyl. And what is nitrosyl pe the charge? Is it a cationic, anionic or a? Anionic. It is a anionic. ना कहाँ पे anionic है?
cationic है अभी तो बता. cationic. Left hand side.
चश्मे का नंबर बढ़ गया. It is cationic. NO is nitrosyl. Also, we have written NO plus in nitrosonium. In majority of cases, NO will be nitrosyl, neutral monodentate. But over here, NO is in the form of nitrosonium. ठीक है. This is brown ring complex. कुछ याद है? हाँ, ठीक है. This is brown ring complex. You have to remember in this one here, NO is nitrosonium +1. ठीक है. This is -2. Now find X for me. X plus 0 plus 1 minus 2 is equal to 0. X is plus. ठीक है. और थोड़ा करेंगे इसके बारे में when we do salt analysis. ठीक है. But you have to remember this one. वही मैंने बोला. For this specific complex के लिए नहीं, एक्सेप्शन नहीं, रीजन है, बट अभी पूरा एक्सप्लेनेशन इस चैप्टर में मैं नहीं दूंगा. हाँ, इट इज फॉर दिस, फॉर ब्राउन रिंग, नॉट स्पेसिफिक फॉर वन. एक दो और एग्जांपल्स है, बट रिमेंबर दिस वन. नाउ एक लिगेंड मिस हो गया था मेरे से, अ बाइडांटेट. प्लीज ऐड दिस. This is called as DMG, dimethyl glycinato glyoxime. glyoxinato. ठीक है. It is a bidentate and it is neutral. Add this and also add this is called as DMG anion. Everything remains the same, only thing here is charge is -1. बेटा ये बाइडेंटेट्स है और ये एक और एग्जाम्पल है फॉर द क्वेश्चंस दैट वी वर डूइंग. ऑल्सो ये आंसर्स है, जस्ट बाद में आप लोग कंपेयर कर लेना. पॉज कर देना सब. So let's continue. The next topic that we have, very good, is effective atomic number, or also called as Sidgwick's theory. तो heading लिखना please, effective atomic number और Sidgwick's theory. क्या बेटा? The central metal atom, or ion, will continue accepting electrons. The central metal atom or ion will continue accepting electrons till the total number of electrons, including those donated by ligands, become equal to
Is it the total number of electrons?
including those donated by ligands, become equal to that of the next noble gas, becomes equal to that of the next noble gas. Next line, I've written a formula on the board. Effective atomic number is equal to number of electrons in the central metal atom, central metal ion, plus 2 into coordination number. Now, let's people understand what exactly is effective atomic number. See, for example, over here, if I ask people what's the coordination number? 6. Aqua is a monodentate. There are 6 of H2Os, so we have coordination number 6. But why only 6? Why not 4? Or why not 5? Yeah, 7 or 8? Or let's say I pick randomly FeCO5. Why only FeCO5? Why not FeCO4? When does a metal stop accepting electrons from ligand? We need to, when, so that's what the theory says. It will stop as soon as it reaches what? The nearest noble gas configuration. So for example, if we talk about 3D, which is the nearest noble gas? That is krypton. Atomic number of krypton, very good, 36. ठीक है. Next, krypton के बाद we have xenon, atomic number, very good. उसके बाद atomic number, excellent, 86. ठीक है. वीडियो में लगना चाहिए कि बच्चे आंसर कर रहे हैं. ठीक है. बट मैं ही सवाल पूछता और मैं ही जवाब दूंगा. Let's start. So, Fe, let the charge on Fe be X, aqua, chlorine. So quickly give me the charge on Fe over here, +3. I'm not going to write the entire thing. I feel अभी आप लोगों को आता है वो. I know I'm wrong, but ठीक है. +3. बराबर? Now, Fe, atomic number please. 26. So 26 electrons, 26 protons. Fe +3, number of electrons. Sorry, I'll change this to Cl2. तो ये क्या हो जाएगा people? This will be +2. So this is +2. So now can someone give me in Fe +2, how many electrons will there be?
24.
Number of electrons in Fe +2 is 24. Okay. Can someone give me the coordination number here? 6. Anyone who did not get this? How do I find EAN? 24 plus 2 into 6, 36, which is krypton. Did you will get that? Bolo re. Next kare. Give the charge on cobalt over here, please. This is 0. Chlorine is -1. So +3. Okay. Number of, so cobalt atomic number 27. So number of electrons in cobalt +3, 24. Coordination number here please.
5.
Excellent, 6. Coordination number is 6. Therefore, what will the effective atomic number be? 24 plus same thing again, people. 2 6 are 12, so answer is 36. So if you reach 36, it's following effective atomic number. If it doesn't reach 36, not following Sedgwick's rule, which means less stable. For example, if I change this to Cl3, that would have been 35, less stable. If it reaches noble gas configuration, more stable. Anyways, however, we'll do a separate topic on stability of coordination compounds in the last part of the chapter. Come on, now solve this for me. Charge on Fe? 0. Fe, atomic number? Number of electrons? 26. How many ligands are there? Each is giving 2. So 2 into 5, 10 plus 26. Did you people get that? कर सकता है? Yes or no? जल्दी जल्दी साथ तक पॉज कर देना. चलो, compare your answers. जल्दी जल्दी. Then we continue with the last part for today. Shlok Somat. Please write down. Werner's theory. Werner's theory of coordination compounds. He is also called as the father of coordination compounds. Now, according to Werner's theory, coordination compound metals, according to Werner's theory, coordination compound metals show two types of valencies. Coordination compound metals show two types of valencies. Primary and secondary. Now divide the page into two parts, two halves. We'll write a distinguish between just say primary and secondary. Around half a page. We just need around half a page. Write on primary valency and secondary valency.
लेफ्ट साइड पे प्राइमरी है.
लेफ्ट में प्राइमरी लिखो. Primary valency is satisfied by anions. Full stop, continue. Groups satisfying primary valency, are usually ionizable in aqueous solution. अब सेकेंडरी वैलेंसी में लिखो. Secondary valencies are satisfied by groups which are non-ionizable in aqueous solution. Groups which are non-ionizable in aqueous solution. Primary valency, next point. Primary valency represents oxidation number. Represents oxidation number. Secondary valencies represent coordination number. Secondary valency represents coordination number. Primary valency are non-directional in nature. Secondary valency directional in nature. They are covalent bonds, no? So they are directional in nature. Okay, now pay attention, please. So let's say we have this particular compound, okay, and we treat this with AgNO3, and what we get is we get white precipitate of AgCl, and that too what we get is we get 3 moles of AgCl. Okay. Now do you remember, people, that in coordination compound the part which is written out of the complex, only that part is ionizable. So if I ask over here, I want to now change this into a coordination compound. Which part will be present outside the sphere? How do I decide that? कितने moles of AgCl मिले? That tells me कि all the 3 moles of AgCl were actually present outside the sphere. Did you people get that? Only then it is possible for them to come out in the form of, for example, if I dissociate this, how will this look like? CO NH3 6 3 plus this with Ag plus will become AgCl. Getting that? So the part which is written outside, इसको हम क्या बोलते थे? Ionizable part, and the remaining part was non-ionizable. We did this in the first lecture, but थोड़ा सा फिर से लिखते. This is also called as part of the ionization sphere, and this is part of the coordination sphere. Did you will get that? Now for this particular complex, can someone quickly give me the oxidation number? What is the oxidation number for the central metal atom? Plus 3. That oxidation number is nothing but also by Werner it was called as the primary valency. And what's the coordination number over here, people?
6.
That coordination number according to Werner was secondary valency. Did you people get that? Now out of the two valencies, one is directional, the other is non-directional. Which one is directional? Primary. Secondary valency. So if I just try to draw the structure, okay, we have central metal atom here is cobalt. The ligands are, so we have NH3 amine, NH3 and NH3 coordinate bond. How many NH3s are there?
6.
Where's the fifth one?
Above the plane.
And what about the last one?
Below the
Below the plane. So their positions are fixed. Remember geometry octahedral or square pyramidal. But this is for the secondary valency wala part. So the groups which satisfy secondary valencies, these ligands, they satisfy secondary valencies. For them the position is fixed. Bond is directional in nature. That was the last point written. But what about the anionic part? It's not fixed. वो कहाँ पे भी we don't know their exact position. CL4. Sorry. So the dotted lines that you see is for the primary valencies, non-directional bonds, and the directional bonds, the secondary valencies will be at fixed positions, जो हम geometry में eventually और आगे पढ़ेंगे. Did you people get that? Yes or no? Copy this and we stop for the day. So instead of go back. Now people, ये जो questions किए थे, these, sometimes even instead of saying like find oxidation number or coordination number, they can say find primary valency and secondary valencies. ऐसे भी पूछ सकते हैं. Getting that?
Yeah.
ठीक है, that's it. Stop for the day. उसको pause कर दो.